if you have, this book was probably written before nice calculators. So if you have a dumb anybody have a basic calculator?
Sure.
I have a nice one.
Well, it's called the change of base formula, but you can use a basic calculator and do just like common logarithm of 27 over common logarithm of 3. And also we're supposed to solve it. It says round to the nearest 10,000th. What does 10,000th mean? What's this decimal place? 10?
100.
So we gotta go to the 4th decimal place. Which is soaking up all the...
I was in a math class once. You know, I'm something of a scientist myself.
Oh, this one comes out nice and pretty because it's base 3, but that's, yeah. Okay, so I'll go through these kind of quick. So number 3 is going to turn into log of 32 over log of 8. So when you use this trick, it doesn't matter what base you use, it always works. Even if they use a different base. That comes out, what'd you guys get on that one? Anybody do it? No?
Hold on, I put in the wrong base.
1.6667.
Yep. It's 1.6 repeating, so the last 6 you round up because there's number 5. Log of 8 over log of 3.
Wait, where do you get the bottom number?
Is the base.
Oh.
This is how you do it without a nice calculator.
I saw that.
1.8938.
Little mouse, number 7. Log base 5 3/4. So, might be easier instead of plugging in 3/4 to just do log of 0.75. Log of base is 5. Negative 0.1787. Alright, number 9. Now on to the action. Okay, so the rule for today is if they give us a problem in exponential form, like number 9, I can write it. We're going to have to change it to log form to solve it. If they give us a problem in logarithm form, we're going to have to change it to exponential form to solve it. So it kind of just flips the thing. So how do I rewrite this as a log problem?
Log 2, 5.
Log base 5
13
of 13 equals x. So all you have to do is plug that in. Or Abby, you have to plug in the thing with the thing.
1.5.
I think we're still rounding to the 10,000s, yeah.
Okay, so 1.5936.
7.
Oh yeah, 7.
I'm helping
Yeah,
you.
make sure you round correctly, Jen. If I'm grumpy, I'll take points off. And I'm always grumpy. I'm like the Hulk. I'm always angry. 7 plus 10 to the x. Equals 257.
So you're going to move over the 7?
Move over 7. Yeah, if we subtract the 7, it will look like number 9, right? And then we can do the log trick. So we just need to get the exponent term by itself. 10 to the x equals 1050. Then what do we do? Yeah, if it's log base 10, it's called a common logarithm. You don't have to write the 10 there.
Oh.
And then on this one, Abby, you don't even have to do the trick because it's a common log. Thirteen. 8 to the 3x equals 60. Oh, I wasn't thinking of Allison. I don't think I marked her down. Or-
That's 14.
Whoops.
Shoot, Allison's not here. Did you know Allison's not here?
I was like, something is wrong. Somebody's missing. Let's figure it out. 4 to the 2x equals 112. Z equals 112. Alright. So this is already kind of like number 9, right? So we can go straight to the log here. So log base 4 of 112 equals. So what do you guys think we're gonna have to do on this one?
Divided by 2.
Right. We gotta get rid of the 2 over here. So you can plug all this in your calculator at once still. It's just that divided by 2.
You just waiting for what?
Zero's the home.
1.71.
018.
0.18. And if
Yeah.
log base 4 of x.
Now we have to do the other one.
Okay, so what's different on this one?
Fraction.
Well, no. It's a log function instead of an exponential function. So in the logs, we're going to turn it back into exponential form.
Oh, I see.
So figure it out.
4.
So what's this as an exponent? You guys know how to do that without a calculator?
Nope.
Remember that 2 means square root of 4, which is 2. 2 to the 5th. Number 7, log 4x equals -2. Katie, why didn't you just sit in Lydia's chair?
That's a different table. Unless I know.
Okay, alright, what's the base here? Invisible 10, right? So it's 10 to the negative 2 equals 4x, invisible 10. Do you guys know what 10 to the negative 2 is? Huh?
0. Negative 160. Or just 160.
1 over 100? Like divided by 4? I feel like I wrote something down wrong. Oh, they changed it to a decimal, that's what happened. Yeah, they didn't write any fraction answers on today, so they did 0.01 instead of
I did that wrong.
0.01 divided by 4 is about that one. Yeah, we want to get this log by itself. So yeah, subtract the 4. That'll clean it up. So this plus 4 is not in the log. If it was, they would have had to done it. They would have had to do parentheses. So it is free to get rid of it. So log of 2x equals 4. Then we're going to change the log to exponential form. What's the base? Invisible 10 to the 4th equals 2x. What's 10 to the 4th? 10,000. 4 zeros. So it's 10,000 divided by 2. These aren't that bad, are they?
No.
You just jinxed yourself. No, not really. The word problems are okay. 21. Round to the 10,000th. Same thing. So 1.5 to the x plus 2 equals 15.5. Did I write that right? So what is the first step going to be?
Log.
Log it, yeah. So log base what?
1.5.
1.5 of 15.5 equals plus 2. So what are we going to have to do on this one? Subtract.
Plug it in and then add 2.
And
Yeah.
it exponents.
Subtract 2. So yeah, do a minus 2 at the end of that.
Okay.
You guys get that?
Why is it negative?
Because I didn't read it right. Oops. Number 23. Nope. Wrong. 37. All right. If a 26,000 sports car loses 15% each year, what's the nearest tenth of a year will be the car? Well, when to the nearest tenth of a year will a car be worth 10,000? So, do you guys remember the exponential growth formula from the last week?
To the t equals times 1 plus, is this the
Okay, what did the P stand for? Principal or
hinge?
yeah, principal is like for an investment, but it's initial amount. R stands for like rate of growth, growth rate, percentage rate, some kind of interest rate, some kind of percent, and then T stands for time. And then when we did compound interest, I think there is one of those on these 4. What was the difference for compound?
Instead of r, it was r over k,
Yeah.
and then t.
KT. So K stood for how many times you got paid in the year. So if it was monthly, it was 12 times a year. If it was daily, 365. Yeah. Quarterly, 4 times a year. So those are the things. So on the first one, is it compound interest or is it just growth. Or percent decay, I guess, in this case, because it says the 26,000 sports car is losing 15% of its value every year. So where am I going to put the 26,000? P. So yeah, we're using this top one. 26,000, and we're losing 6%, 15%.
So 0.15.
Yeah. This would be minus 0.15 since it's going down 15%. Move the decimal twice is 0.15, but it's going down, so it's like 1 minus 15%. And then to the t, does it say we have to write that? Oh, we don't know what t is. But we want the value. It's a mess. Okay. We want the value to drop down to 10,000. So the question is, how many years before this is going to happen? We could have simplified the parentheses a little bit. What's 1 minus 0.15? 0.85. So you could just make it a little simpler. Not that it really matters. So if something is dropping 15% every year, it's only going to be 85% of what it was the year before. Okay, so how do I solve this for t?
Log.
Okay, well, first off, we want to simplify it, like we want 5 to the x. We want to get the exponential thing by itself.
So divide by 26.
Yeah, 26,000 is multiplied to this guy, so let's clean it up by dividing 26,000. That would be some weird decimal, but it does reduce to 5/13. You can put the decimal if you want to, but either way, it's that. All right, then what were we doing?
Did you do the log from here?
We turned the exponential into a log function. So log base 0.85 of 5/13 gives us the time. Rounding to a tenth of a year. 5 point is around to 0.8 or 0.9?
8.
0.8?
8. No.
Should be 0.9. So it takes almost 6 years for the car's value to drop from $26,000 to $10,000. 39. You guys are gonna miss the conclusion.
Oh no.
39. It's the tricky one you might want. Okay. So on 37 it says an investment of $D is compounded annually. So if it's compounded annually, that means you're just getting paid once per year. And if you put a 1 in for K, like right here and right here, that doesn't really change. That's just a simple, it's just, we can just use this formula. You could put a 1 in there and there, but compounded annually is just like a normal exponential growth formula. If it's compounded monthly or whatever, you gotta put the 12 in there, but annually you don't really need, putting 1s in there doesn't really do anything. So the initial amount is $D. Where am I gonna put the D? In the front, it's the initial amount. And it's supposed to be getting paid 6% APR, 6% per year. So what am I gonna put for the 6%? 0.06. I don't think we know the time on this one. But it says, how long before, let me read it. How many years to the nearest tenth of a year will it be until the investment doubles? So what do I want to put over here for the investment being doubled? No? I think somebody might have said it. Not quite.
Like square.
Getting colder. This was the investment, right? This is like the initial amount. So it's 2 of those. All right. Any right ideas? I have D on both sides. Can I do anything about that?
Minus.
You could probably subtract a D.
No.
Uh,
Okay, remember on the last, okay, this D is multiplied to this, right? It can't be subtracted. Remember on the last one how we cleaned it up by dividing by 26,000?
So
Divide by D. What's gonna happen? Bam. Bam. Dramatique. And, okay, 1 plus 0.06. Let's just go ahead and put it 1.06. All right, I'm out of space. So, now what do we do?
play with the board.
Bounce, bounce, bounce. Kitty bounces. Now what do we do? Oh, log, yeah. You said it. All right, so log base 1.06 of 2 equals T. How long before the investment doubles with 6% interest?
What do I go to?
Tenths.
9.
Okie dokie.